So right now, I'm gonna have you try this out, and then after, I'll go over the answers. So same thing, just what are we given, what are we finding? If you want to read the question, then what are we given, finding, and formula.
Okay, so we are given 4.62 times 10 to the 14. That goes with that? Okay.
Yes. It might be helpful to actually put the symbol, like, okay, what is that? To help us figure out the formula.
Oh, okay. So that's frequency, so I do the little thing.
Yes.
Okay, and then we're looking for the wavelength, which is this thing, in nanometers.
Mm-hmm.
And the formula, okay. So, oh yeah, okay, so it's just the one we've been using.
Is it that one?
Oh, just kidding.
Yeah, why isn't it that one though?
Because we're not looking for energy.
Exactly, we're not looking for energy, we're not given energy, yeah.
Oh, whoops, okay. All right, so it's gonna be, which one has frequency and wavelength?
Yes.
Am I missing something? Wavelength? The other, that's velocity. Oh, so it's the first one, okay.
Yes. Mm-hmm.
I was looking at the other V. Okay, here we go. So, I just plug it in?
In this case, yes.
Okay.
Yeah. There's nothing, I know, there's no trick.
I'm like, wait, there's something I need to convert here. Okay.
Yeah, because it's not in hertz, it's already in seconds to the negative first, you're fine to plug in.
Cool. All right.
Yeah, you can plug in, or you could have also rearranged the formula. It honestly doesn't matter. Both works.
Oh, well, how am I going to do it if I don't rearrange it?
You would, if you want to rearrange it first, that's totally fine. I prefer it.
Yeah, I think I should. Okay, but I don't remember what it looked like.
Good.
So it ends up being this. Like that?
Yes, that's right.
Okay. All right, so let me do this thing again and move that over. Because this is the velocity. Okay. Over the c, which is the speed of light.
Yes. So you can use that one or 3. It's just going to be dependent on whatever he typically uses.
Okay. Yeah, honestly, I feel like I've seen both, so I don't even know at this point. Okay. All right, so now I just put it in my calculator.
Mm-hmm.
Oh, and then I'm gonna have to convert at the end.
Yes.
I see.
Now you see it. Good.
So would I round right here then?
Yes. To how many sig figs?
Oh, 2, 3.
Yes.
So it's gonna be 6.49 times 10 to the negative 7. And that's in meters.
Correct.
So now I put it in nanometers.
Good.
Okay.
Perfect.
Oh my gosh. Okay, I was like, it always goes with the base unit.
Good. Yeah, now it's making sense.
Okay, yeah, you're right. It's so much easier if you just like remember that. Okay, so the official wavelength, I cannot draw those symbols very well. 6.49 times 10 to the 2 nanometers.
So just that's correct. That is completely correct.
Okay.
Since you do get multiple choice questions, how would you change this from scientific notation to standard notation? And remember, standard notation is basically just like the typical number we've seen, like 104, or...
Yeah. That's a good question.
It's a great question, yeah.
I think, because this is like what I practiced when I first started, like the first week of school, like trying to remember how to do this. I feel like, because it's different whether you move it 2 over to the right or 2 to the left, and that's all I can't remember. So I think it's, you move it 2 to the left.
So here's another trick for you. Remember how I said, like, the larger number, like if it's a positive number, like 2 in this case, it's a larger number. If it's a smaller number, it will be a negative exponent.
Oh, so it's to the right.
Yes.
Okay, so it's just 649 nanometers?
That's it. Correct.
Oh. I'm glad you asked me that, because this is the kind of like, I need that.
Yeah.
Yeah.
It's the little things, that can get you. But yeah, this is what your answer should look like. And even on like the multiple choice, because I don't want that to stop you.
Right.
It would suck. Like, hey, I got the right answer.
Cool. Okay.
Next one. Perfect. You did that one perfectly.
Awesome. Okay. So calculate the wavelength. Wait. All right. I'm not going to think about this. I'm just going to do the thing. Not try to make sense of it. Okay.
The mercury lamp, it doesn't matter the type of lamp. Just
do the thing.
Just do the thing. You're going to get the most interesting word problems eventually.
Yeah, I'm like, what? Okay.
Who makes this up?
Okay. We are given a frequency of 6.88 times 10 to the 14 hertz. And we are being asked to find the wavelength. And since it didn't specify, we assume it wants it in nanometers?
Yes.
Okay.
And then, I mean, of course, since you have multiple choice, it's going to be pretty obvious, but...
Right.
Just in case.
Yeah. Okay. And then the formula. Okay, so let me see here. Wavelength. Oh, it's the same one, isn't it?
Yes.
Okay. All right. So.
Good.
Now, hold on, because I know there's something going on here.
Yeah. And don't look at my face. It's like, just look at the problem. I'm just kind of like, come on, you got it.
Okay, so we need things to cancel here.
Yes.
The C is in, what is M/S again?
Meters per second.
Meters per second. Okay, so hertz. Oh, so am I just going to write it as 1 second to the -1 or something?
Yeah, so seconds to the negative first, correct. You'll just convert it. So you literally could just swap out, like honestly, you could literally just swap out the hertz for seconds to the negative first, since it's all 1 to 1.
That's what I was thinking. Okay, yeah, so I don't have to literally like write out a conversion, like, because it's just, okay.
No, I did that just to show you where it came from. And
right, okay. All right, so I'm just going to do 6.88 times 10 to the 14th, like that.
Yes.
And then over our C, which is...
But I want you to think of the formula.
What do you mean?
So we...
Oh, whoops.
No, the formula for, like, if we want to rearrange it, because it's not set already to solve for wavelength.
Oh, yeah.
Which is fine. If you wanted to try it this way, I can show you how we could still do it.
That I would ultimately end up realizing eventually that, like, it wasn't right. Okay, so let's move that over again. This is, like, the whole purpose of me writing what we're trying to find.
Right.
Okay, so this here is my velocity. Oh wait, I forgot how we changed it. So it ends up being the wavelength equals velocity over... No,
Try it again.
it's this.
Remember that is frequency.
Oh, just kidding.
Okay.
Oh my gosh. Okay,
That's why I highlight things. It's totally fine. It happens a lot.
there we go.
Yes.
Okay, so this is what we are doing now. Over the C, which is the 3.0 times 10 to the 8th meters per second.
Perfect.
Now we're going to end in meters. Divided by 6.8 times 10 to the... Okay, and we're going to do 3 sig figs.
Good.
And now I would have to convert it, right?
There was a, hold on. There was a 1? You didn't get squared? Or actually, did I?
Maybe I probably put it in wrong. Hold on.
Let me double check.
I always do this. I don't know why, it just happens. Divided by 6.88 times. Wait, what? I just got something completely different now.
-7?
Yeah.
Yeah, okay. Yeah. So it's like 21. Where'd that come from? Yeah.
All right, so that's me typing in the calculator and not being really slow about it. Okay, there we go.
Cool. And then last step.
Converting it.
Yes. Well, now you have 30 extra minutes to check that. So it's a good thing.
Yes.
Perfect.
Okay.
And how would you write that in standard form? Good.
Yay.
That's it.
Okay. Oh, we're starting with given. Okay. We are given a frequency energy of a wave.
Doesn't say photon. It doesn't say anything. It's just energy.
So we just say joules.
Yeah. Well, you can think of like E, right? But the measurement or the unit is in joules.
Okay. So do that. Okay. I don't know.
It's fine. Yeah. Just knowing it's energy that we're solving for, but it's in a unit of joules. Yeah.
Okay, cool. And then the formula, let me move this over. Oh, we're gonna do, I think, oh.
Yeah. We haven't used this formula yet. Yes, good. That's right. We haven't used this yet, but same sort of idea applies. Good, and
Oh, okay, it's okay. I know what to do.
good.
Nobody panic. All right.
Good, because we know 1 hertz is equal to 1 seconds to the negative first. Good.
Yes, okay. So now the tricky part, apparently. Let's see if we can put this in here, right?
No division, just multiplying. Yeah.
Yeah, true. Let's see if I can do this.
Here, I'll double check with you.
Probably be a good idea.
Good. That's correct.
And we're gonna just do 3, so it's gonna be
Perfect. That's it.
awesome. I am so proud of myself. Like, this is so good. I can't believe that, like, I'm actually getting the hang of, like, the steps.
Yes.
Okay. Next one.
Yes. Last one.
Okay, we did one like this in class today. I had no idea what they were doing, but I'm about to find out. Okay.
They talked about a laser.
Yeah.
Okay.
Given formula. So given 636 nanometers, and that's our wavelength,
Perfect.
and 3.8 times 10 to the negative 6 joules.
Mm-hmm.
Number of photons.
Yes.
Okay. So. Oh, this is the multi-step one.
Yes, it is. Good. 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 So you already know. You're off to a good start.
Oh, man. But I don't. Okay.
What formulas do you remember that we, even if it's just one?
We definitely did the number of photons E given over E photon. But that's at the end, after we find those.
Perfect.
So I remember, like, we do something, then we convert something, then we do something, then we convert something.
Sure. Welcome to chemistry. Yes.
Okay.
Okay.
So we're given an energy already, right?
So,
Yes.
We already have our energy given. I know it sounds ridiculous, but yeah, like from that formula of the number of photons, E given divided by E photons.
Okay, yeah, we have that.
But we don't have the energy of our photons. So that's what we have to find.
So we have to find that the energy of the photons first, put it in the formula, and then find the number of photons. Okay, cool. So we need one of these that involves energy.
Energy, and then we're given... What are we given?
We're also given energy. What?
And we're given what else?
We're given wavelength.
Yes. So that wavelength is going to help us determine the energy of the photons.
So I'm going to have to pick one of these and then rearrange it, right?
You don't need to in this case. So what's the one that we use when we're given the wavelength and we're finding energy?
Oh, okay. Well, I was confused because I see that we're also given an energy. So do we not do anything with that one?
No, not until the second step. So that's the one that we use for the number of photons formula. That's E given.
Okay, and then we're going to do this one after.
Yes.
Okay.
Cool.
So, here we go. So I'm just going to put E equals H.
Okay.
Okay.
You're about to tell me I didn't convert something, aren't you?
No, you're
good.
You're good.
Okay. Do I have to put that point in 0? I mean...
Or actually, sorry, you're not good. You're not good because... Why?
Oh. That needs to be in meters.
There you go. Yeah, top part was fine, but it needs to be in meters. Mm-hmm. Good. Perfect.
Okay.
Cool.
Now I'll do that, and then I'll be able to plug it in the other one.
Yes.
Okay. Here we go again. Let's see. 6.6. I'm going to really take my time. So would I round right here? Or no.
I didn't. Could you?
I feel like my teacher says, like, don't round until the end, like, for, you know what I mean?
I would say don't.
Okay.
Yeah, I would say don't. Typically, you do round to the very end.
Okay. Is that what you got?
Yes.
Okay, good. All right. So now we do E given. So the number of photons equals what we were given, which is the 3.8 times 10 to the negative 6. Oh, wait.
You're right.
Oh, okay. I was making sure that was still in joules. Okay. Wait, but then, oh yeah, everything cancels because then we're left with photons. Oh my gosh. Can you believe I did this?
I can. I really can.
Okay, let's see. Divided by... All right, I feel like this isn't right. I feel like something went wrong because last time I got a number like this. Am I wrong?
No, you're good. Keep going.
Okay.
Good. Yeah.
Wait, I need
Yourself.
3 sig figs so that this is actually going to be. Yeah?
13. No, it is. It's right. Hold on. I'm just looking at your sig fig rounding. No, that's right. You're good. That's correct.
Yay!
Good. Okay.
Oh my
Very good.
gosh.
I mean, I can tell it's making sense, but okay. So it's pretty much just, I mean, you're pretty much just plugging it into formulas. It's knowing what formula and then when to convert things. It's essentially this whole entire concept. I'd say for the next lesson, we'll get more into like quantum numbers. I didn't want to do that today because I figured it would be too long, but yeah. Any questions so far? How are you feeling about this section now?
I feel so good because like we've been doing this all week this week and I've not had any idea like how to do it. So now I actually get it and I can practice now because I know how to do it. So yeah, I just need to work on memorizing those formulas. And then I think like whenever I get to my test in front of me, I'll probably just write those down right away so that they're in front of me.
Yeah.
But no, I feel so good. And now I have these notes so I can just go back to them and look, you know, when I want to practice.
Perfect. I really hope you're enjoying this series so far. And if you are, then please give this video a like. And don't forget to turn on your notifications, ring that bell, because you never know when I'm going to post the next video and when that's actually going to be on your next exam. All right, I'll see you in the next video.